So yesterday we solved some second degree trig equations which involved Pythagorean identities. Today we're going to solve some second degree trig equations that contain double angle substitutions. So now at first glance this doesn't look like a second degree equation because there's nothing being squared. But our list of substitutions will provide the double angle which will yield a second degree equation. So double angle means that the angle is being multiplied by 2. You cannot call this out as a constant multiple. You cannot manipulate this angle. This is 2 theta, not squared theta. So this is very different than that. That means cosine is being squared. This means the angle is being doubled. It's being multiplied by 2. So what we'll have to do is take a look at our substitutions, and judging from yesterday, if this were cosine squared, we'd still have to do a substitution because of the first degree term. The first degree term here being sine leads us to believe that all of our functions should be in terms of sine. So the same applies here with the double angle. So here's a list of substitutions that you should copy down real quick. Take a moment, jot down the functions of the double angle, which include sine, cosine, and tangent double angle identities. So pause the video, copy it down. So now what we'll do is take a look to see there's a bunch of cosine double angle identities here. We want the one that contains only sine. That's our first degree term. This is what we want everything in terms of. So if we take a look, we have cosine has 3 substitutions here. So which one do we use? Well, that one's got cosine and sine. This one's got only cosine, and this one's got only sine. So that's the one we're going to use right here. 1 minus 2 sine squared. So cosine of 2 theta is equal to 1 minus 2 sine squared theta. So that means cosine 2 theta is that. I'm just going to plug that in. So let's see what we get. 1 minus 2 sine squared plus sine equals 0. So now we have a function that contains only sine, so we can factor this like we did yesterday. So just another point here. Take a look at the domain that's given. This is telling us to solve for all values of theta between 0 and 2 pi, which means we're going to solve for a degree measure and then convert it to radians. And if we get 0 as a solution, say 0 and not 2 pi. So let's factor this thing by putting it into standard form. I'm going to change the order around, and I'm going to convert it to an x squared term just to make it easy to factor. So we have 1 minus x squared, 1 minus 2x squared, plus x equals 0. So negative 2x squared plus x plus 1 equals 0. Let's multiply everything by negative 1. 2x squared minus x minus 1 equals 0. Let's use the payback method. So we have a trinomial of x squared minus x minus 2. And that yields factors of x minus 2 times x plus 1. Divide back by the 2, giving you x minus 1 and x plus 1/2. But not x, we're using sine. So we're going to say sine theta minus 1 times sine theta plus 1/2. Don't forget it still equals 0. So now we'll set each of these equal to 0 and we'll solve separately. So sine theta minus 1 equals 0. Sine theta equals 1. When you're working with 1, 0s, and negative 1s for sine and cosine, don't use the inverse sine function. Refer to the unit circle. So sine is a y-coordinate. Y-coordinate is 1, only once. So we get theta equals 90 degrees. Now we have sine theta plus 1/2 equals 0. So sine theta equals negative 1/2. Now if we take the inverse sine, we're going to get ourselves a reference angle. But before we do that, sine is a negative number. That means we're working in the 4th quadrant and we're working in the 3rd quadrant. So we're looking for this kind of an angle and this kind of an angle. Once we find our reference angle, we're going to go down that many and down that many. If we take the inverse sine of negative 1/2, we should get inverse sine negative 1/2. It should provide theta equals negative 30 degrees. Well, we don't want a negative angle, but that is this angle. Negative 30 degrees. That's simply our reference angle. We have a reference angle of positive 30. Reference angle is a distance, so make it positive. The angle of rotation is negative 30, but it's also the reference angle, a distance of 30. So let's find a coterminal angle and say 330 degrees. Well, if 30 is our reference angle, we're in the third quadrant. This is 180. We're 30 past that, so 210 degrees. Finally, we need to convert to radians here. So one thing you can do, just a little shortcut to use the calculator, use the math function, or just multiply by hand, pi over 180. So 330 pi over 180, 210 pi over 180, or 90 pi over 180. So let's convert all of these to radian measure. Well, 90 is pi over 2, we know that from graphing. 210, if we want to convert this to radians, what we can do is 210 divided by 180, enter, math, change it to a fraction, and 7 pi over 6. That's 210. Now let's convert 330 to radians. 330 divided by 180, enter, math, change it to a fraction. 11 pi over 6. Another way you can do it is think that we're increasing by multiples of 30 degrees here. 330, 210, 90. You can add pi over 6 until you get there. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So you can just keep adding a pi over 6. Next example. Again, we have a cosine double angle here. This is not being squared, the angle is being doubled. And also, our domain is asking for a radian measure as our solution. So let's use a double angle substitution for cosine 2 theta. So before, we were looking for a sine function. So take a look at this. Which function we're using here? Cosine. That's our first degree function. That will tell us what we want everything in terms of. So in this case, we're going to use this identity here. 2 cosine squared minus 1. So not cosine 2 theta, 2 cosine squared theta minus 1. And then copy the rest. Let's just combine like terms. We have canceling 1s here. So we have 2 cosine squared theta plus cosine theta equals 0. No need to change this in x because we have a common factor of cosine. So let's factor out a cosine, leaving us with 2 cosine plus 1. Don't forget it's still equal to 0. So now we have 2 factors, we'll set them both equal to 0 and solve separately. So cosine theta equals 0, and 2 cosine theta plus 1 equals 0. Let's solve this side first. 2 cosine theta equals negative 1. Cosine theta equals negative 1/2. Before I take the inverse, I'm going to identify which 2 quadrants we're working in. Cosine is negative. Where is cosine negative? Well, it's negative in the second and in the third quadrant. See, these are the 2 angles that I'm looking for, in which our reference angle will tell us how far to go up and down. If you take the inverse cosine of negative 1/2 in the calculator, you should get 120 degrees. That's not your reference angle. That's your angle of rotation. So if this is 120, how much is left for that? 60 degrees. So our reference angle is 60 degrees. We already found our second quadrant angle. Let's find our third quadrant angle. Well, if our reference angle is 60, and this is 180, we're 60 past it. 240. So these are our 2 degree measures for this side. Remember, we have to convert it back to radians. Let's solve this half. It says cosine 0. 1 zeros and negative 1s refer to the unit circle. If cosine is 0, that's telling us that x is 0. Well, x is 0 there, x is 0 there. That is 90 and 270. Put in radian mode. pi over 2, and 3 pi over 2. Let's convert these to radian measure as well. Again, when you're increasing by multiples of 30 degrees, you can just add pi over 6. So 30 is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So this is 30, 60, 90, 120, 150, 180, 210, and another pi over 6 would be 240, so that's 8 pi over 6. So my two solutions are 4 pi over 6 and 8 pi over 6, and I'll just reduce those two fractions to say theta equals 2 pi over 3. And I'll reduce this fraction to 4 pi over 3. Probably would have been easier to increase by pi over 3 because these multiples is 60 as well, but either way. So we have a solution set of theta equals pi over 2, 3 pi over 2, 2 pi over 3, and 4 pi over 3. Okay, so you're finding the degree measure just like you would normally, but you're converting it to radians depending on how the question is displayed. One more example. So now we have a sine double angle. A little different than the cosine double angle, but same concept. We want to use a sine substitution, and we're going to express our answer in terms of degrees here. So let's take a look at our list of substitutions. So cosine, there was a choice to me. Sine, only one substitution. It's 2 sine theta cosine theta, and that's it. So sine 2 theta is 2 sine theta cosine theta, and that's equal to sine theta. So I just perform my substitution. 2 sine theta is a substitution of 2 sine theta cosine theta, and now we can subtract sine from both sides. And we can factor out a sine. So we're going to set them both equal to 0. Sine theta equals 0. Let's refer to the unit circle. If sine is 0, that means y is 0. Y is 0 there, and y is 0 there. So this half, we get theta equals 0 and 180. Make sure you're using 0 and not 360, because that's what they asked for. They could have easily included 360 instead of 0, so you have to read to see which of these angle measures is the acceptable solution, because they're the same angle. But y coordinate is 0 here, y coordinate is 0 there, that's 0 and 180. For this half, 2 cosine theta minus 1 equals 0, 2 cosine theta equals 1, cosine theta equals 1/2. Well, cosine is a positive number. So let's find out what two quadrants, quadrant 1 and quadrant 4. So we're going to have a solution that looks like this and a solution that looks like that, which our reference angle will tell how much to go up and how much to go down. Let's take the inverse cosine of 1/2. And you should get a reference angle of 60 degrees. So we're going to go up 60 and down 60. Well, up 60 is 60 degrees. Down 60, well, this is 360. 60 before it is 300. So there we go.